Alright, good morning and welcome to mathsatoka online class. In today's video, we'll be talking about addition and subtraction of matrix. Okay. If today is your first day of watching our video, please consider subscribing, and you can go and watch our first video on definition of matrix and how to arrange a matrix. Now, for matrix A and B to add, okay. For matrix A and B to add, for matrix A and B to add, okay, to add or subtract, comma, the dimension of A must be equal to the dimension of B, okay. The dimension of A must be equal to the dimension of B before they can add or subtract. Now, what do we mean by dimension? Dimension means that if, for example, if A is a 4 by 3 matrix, B is supposed to be 4 by 3 matrix before they can add. The number of row and column of A must be equal to the number of row and column of B before they can add or subtract. Okay, so let's take some examples to illustrate what we are saying. Solution. Now I have that example. I have that matrix A is 1, 2, 3, 4, 5, and 6, and matrix B is 7, 8, 9, 10, 11, and 12. Okay, then matrix C is minus 3, 2, 0, 5, 8, minus 1, 3, 14, and 7. Okay, then matrix D is equal to 2 minus 4, 8, 4, 6, 1, 0, 3, 1. Okay, then matrix E is equal to 4, 6, 8, 2. Okay, 2, 1, 0, 6. Okay, minus 4, minus 3, 1, 3. Okay, then matrix F is equal to matrix F is equal to minus 5, 2, 0, 1, 3, 4, 7, 6, 8, minus 1, 3, and 2. Okay, so we have all these matrices. Okay, now the question here now said evaluate the following. Evaluate the following. They said A plus B 2A minus 2B. Okay, C 3C plus D. E. Okay, D. They said 3F. Oh, sorry. F minus 3E. Okay, then okay, then I said E, find separately the symmetric matrix of X okay, symmetric matrix of X and anti or screw metric, symmetric metric matrix Y, okay, X Y such that C is equal to X plus Y, okay. That is a question here. This is question number 2. This one is 1A, 1B. So then the D part said D is equal to X minus X plus Y. Okay. Solution. Now we want to find A plus. Let's find A plus B. Now in matrix, why the dimension must be the same is because we add or subtract them component by component. Okay, look at what I mean by that. Look at A. A is 1, 2, 3, 4, 5, 6. Okay, plus B, which is 7, 8, 9, 10, 11, 12. Okay, so now to add them is what? Component by component. Anybody in their position. 7 plus 1 plus 7, 8. 2 plus 8, 10. 3 plus 9, 12. 4 plus 10, 14. 5 plus 11, 16. 6 plus 12, 18. Okay, so as simple as that. The answer is very, very simple. And if you notice that the dimension of A and B, if they ask you the dimension, the dimension of A is still equal to the dimension of B, is still equal to the dimension of what? B, and which is what? It is a, how many rows? 1, 2, 3. It is a 3 by 2 matrix. Okay, the column is 2 and the row is 3. So don't forget that we count the row first before the column. So that is that, as simple as that. Are you getting it? So I can clean here. Let's solve number 2. Number 2 said that we should find sorry, did we use C and D? So let's change this to C and D, please. A, B, C, D. Okay, there is C and D there. Okay, there is C and D there. Let's have okay. Let's still have 2A minus 2B. Okay, so now let us do that, or let's say minus B. Anyone. So therefore 2A minus B is simply 2 into the matrix of A, 1, 2, 3, 4, 5, 6, minus B is what? 7, 8, 9, 10, 11, 12. Okay, so as simple as that. So what do we have now? We are having that this time this is what? 2. 2 times 2, 4. 2 times 3, 6. 2 times 4, 8. 2 times 5, 10. 2 times 6, 12. So this is what I'm having. Minus 7, 8, 9, 10, 11, 12. So if you do this now, don't say because this one is the big one, then I say 7 minus 2. No, it's not correct. 2 minus 7, which will give you minus 5. 4 minus 8, which will give you minus 4. 6 minus 9, which will give you minus 3, 8 minus 10, which will give you minus 2. Don't mind my board, that is small. 10 minus 11, which will give you minus 1. 12 minus 12, which will give you what? 0. So that is the matrix. Okay, that is the matrix. Okay, so let us continue. The next one. So please do this one. Do C and D for me. Okay, and send me the answer on the comment section. So the next one now is, now don't forget that before you add or subtract, the first thing you will check is the dimension. Okay, if the dimension are equal, then you can now add or subtract. For example, if I say A plus D, it can never work. Why? Because the dimension of A is not equal to the dimension of what? Of C. So they can never add or subtract. Okay, so that is that. So the next thing we are going to look at is the number 2. The number 2I that said that we should okay, they said we should what? Find separately the symmetric matrix X and the anti-symmetric matrix Y, such that C is equal to solution. They gave us that what? C is equal to what? X plus Y. Okay, and they say we should find the symmetric matrix. So for us to find X, we have to do this. They said that X is a symmetric matrix. So for us to find a symmetric matrix, what do we do? Look at that. Using C, let us use C. Using C. If we use C now, permit me to clean the board. Let me write out my C somewhere and then solve it here. This is minus 3, 2, 0, 5, 8, minus 1, 3, 14, and 7. Okay. And then let me write D. That's the only thing I'm using. 2 minus 4, 8, 4, 6, 1, 0, 3, 1. Okay. So I want to use these two. So let me clean here and make use of this side. Now, okay, now using C, okay, and we know that our C is this. Now we want to get a symmetric matrix that is X. Okay, from that C, look at my C. My C is minus 3, 2, or let me write it here so that I'll be seeing it. My C is minus 3, 2, 0, 5, 8, minus 1, 3, 14, 7. This is to get a symmetric matrix from this C is obtainable. Why? Because C is a what is it called? Is a square matrix. That is 3 by 3 square matrix. And symmetric matrix said that anything that is in the left hand side must be the same thing in the right hand side. Okay, so anything you do to the left hand side, do the same thing to the right hand side. Okay, so how do you do that? Now we get it by saying, let me write out my diagonal first. This is minus 3. Okay, this is minus 3. Now for me to get the same thing here and here, it's just to add both of them and divide it by 2. Okay, so for the side of 2, you know, these two go together, these two go together, and these two go together. So I will say, for here I will say that it is what? That is simply 2 plus 5 divided by 2. The same thing here. 2 plus 5 divided by 2. Okay, for this side you do the same thing. This side will not be what? 0 plus 3 divided by 2. Okay, the same thing is applicable here. It must be what? 3 plus 0 divided by 2. Okay, so don't forget that the diagonal remains the same, 8. What do we have here now? Minus 1 plus, this and this go together. Minus 1 plus 3 divided by 2. The same thing here. Minus 1 plus 3 divided by 2. So leave your diagonal 7. So let's see what the answer will give us. X is equal to, I'm having minus 3 here. This plus this will give you 7. 7 divided by 2 will give you 7 over 2. Okay, so here is 7 over 2. Now this plus this divided by 2 will still give you the same 7 over 2. Okay, so what do we do again? This plus this will give you 3 over 2. The same 3 over 2 here. So what do we have here? 8. Here will give you 2 over 2, which is 1. Which is 1, and here is 7. So if you look at this, this is what? A symmetric matrix. In a symmetric matrix, don't forget, the diagonals, once you bring out the diagonals, you will see that all the entries of the upper triangular is the same thing as the one in the lower triangular. That is when you conclude that it is what? A screw matrix. Okay. So now for us to get y, for us to get y, now we have gotten x. For us to get y, they say that c is equal to what? X plus y. So for us to get y, y is simply what? C minus x. Y is simply c minus x, and I hope you can do that c minus x. Okay, so let us do it anyways. So let us do that c minus x. Where do I do it? Okay, let me do it here. So y will now be equal to what? Y will now be equal to, what am I saying? C. What is my c? I've even cleaned it. My c is simply minus 3 2 0 5 8 minus 1 3 14 7. Okay, then minus my x is what? Minus 3 7 over 2 3 over 2 7 over 2 8 1 3 over 2 1 7. Okay, so let us subtract this minus this 0. 2 minus 7 over 2. 2 minus 7 over 2. The LCM is 2. So you have 4 minus 7, which is what? Minus 3 over 2. So I'm having that 2 minus this will give you minus 3 over 2. Okay? 0 minus this will give you minus 3 over 2 again. Okay? 5 minus this will give you what? 5 minus 7 over 2, which will give you the LCM is what? The LCM is 2. I'm having 10 minus 7, and 10 minus 7 will give you what? 3 over 2. So I'm having 3 over 2 here. Okay, then my 8 minus 8 is what? 0. Then which one do I have again? How did I get 1 here? Okay, it's 1. So what do I have now? The next one is minus 1 will give you minus 2. Okay, then the next one is what? 3 minus 3 over 2 will give you what? 3 minus 3 over 2, which will give you, this times this is what? 3 times 2, 6 minus 3 over 2, which is what? 3 over 2. So I'm having that here is what? 3 over 2. So if here is 3 over 2, then 7 minus 7 is 0. Okay, then 14 minus 1. How did I get 14? Is that 14? I'm not sure that thing is 14. Let me check this. That is for my C. Okay, it's 14. So 14 minus 1 is 13. There's a mistake somewhere in getting my x. So what did I use there? How did I get minus this? Okay, look at what I'm supposed to do. These two. That's the mistake I made. So this is 14 minus 1 divided by 2, which will give me 13 over 2. So here is 13 over 2. This is 13 over 2. I think there is a mistake somewhere, because they are supposed to be the same thing. Okay, they're supposed to be the same thing. I don't know where the mistake is coming from. What did we do initially? This plus this divided by 2. This plus this divided by 2. This plus this divided by 2. You have this. Okay. That's 13 over 2. And the same thing is happening here. 13 over 2. Okay. So what I have here is 13 over 2. The same 13 over 2. Okay. So that we are going to have that here is this is 0, and we're going to have that 13 over 2. So what are we subtracting? 14 minus 13 over 2. Okay, so let's say minus 1 minus 13 over 2, which will give you, this time this will give you minus 15 over 2. So I'm having minus 15 over 2 here. So let us do this one, 3 and this. There is a mix up somewhere, but they are supposed to be the same thing. Like anything that you get here must be the negative of what you get here to show that it is a screw matrix. Okay, so you can try the second one. I think there is a mistake somewhere. No, my board is very small. So in our next video, we'll talk about multiplication. So addition and subtraction is very simple. Just know that you are adding the components and the dimension must be the same. So thank you very much for watching.